Hi, good evening, friends. Okay, uh, yeah. So once again, welcome to the misconceptions. So this is misconception in thermal physics, eighth problem. Okay. So the fraction of the internal energy. What is internal energy? Internal energy is nothing but the energy present in an atom or a molecule. Okay. That is due to molecular vibration. Molecular vibration. We are talking about molecular vibration, which means what? You have a molecule. This starts vibrating like this, up and down like this. Varies in different states of matter. Okay. What gives the order of highest fraction? Okay, highest fraction. Let us say it's something like total internal energy is, let us say, 100 joules. I'm just giving some example. Total internal energy is due to 100 joules. And this is due to, let us say, internal energy due to vibration, due to translation, due to rotation. You have a molecule can vibrate, it can move. Move means translation. Okay, kinetic energy. Rotate, it can rotate. So for anything to happen, you need to provide some energy, right? So let us say the substances that you have in hand, like solid, liquid, and gas, they all have some energy, and as a result of this, the particles can either vibrate or translate or rotate. All the three or either of them can happen. Okay. Now he is asking about highest fraction, which means what? Let us say vibration is something like it takes 10 joules, okay, and translation, let us say it is 50 joules, and the rest 40 joules is over here. Okay, so that the sum of them is equal to 100 joules. When I say fraction, fraction is nothing but 10 by 100. Okay, this is what is called as fraction. Okay, now he is asking which of them gives the highest fraction. Okay, whether in solids this fraction is much higher, that is energy required for vibration divided by total energy. That's what we call as fraction. Okay, is it higher for solids or liquids or gases? So there are four options given. Which of them do you think it's right? So most of the students, okay, when we looked at it, they had answered this as a right option. Option D. Why? Because the molecules present in gas. I got reasons in two ways. The first reason is they said that molecules present in gas are very farther away. They have a freedom to move. And as a result of it, they vibrate. And hence, they should have a larger kinetic energy or larger internal energy. That's one answer I got. The second answer was much more interesting. The interesting answer here is that, see, what happens is when you have a solid, you heat it. That means what? You are giving some energy. So let us say ice. Okay, you are giving some energy. That energy goes in melting this ice to water. Now it water. Okay. So therefore, let us say you are given something like around 80 joules of energy to it. Now it goes. Now the energy present in it at 0 degrees centigrade is 80 joules. Next, what you do? You still heat. Okay. When you still heat, what will happen? Now this energy now increases the temperature of water. It is still once again water. Still once again water. So for this, maybe you should have given much more energy. Let us say, for example, something like 5,000 joules here. Now what happens? This is at 0 degrees centigrade. This is at 100 degrees centigrade. Now what happened to this 5,000 joules? 80 joules converted ice to water. So that is stored or hidden in this. Until unless you don't extract this energy, it will be remaining in the watery state only. Okay. Now you are supplying 5,000 joules to it. Then when you supply 5,000 joules, then what happens? The water which was at 0 degrees centigrade gets converted to 100 degrees centigrade. Now let us say you supply another 10,000 joules. Okay, then this water gets converted into vapor. Vapor. Now it's nothing but gas. So the students, what they told to me is that, sir, if that is the case, then gas should have more amount of energy. What is the internal energy? Energy occupied or energy present in a given substance. As compared to solid, solid will have lesser energy, this will have more energy. So the answer should be option B. Do you agree with this? This is a misconception. Okay. The logic here, so remember what they have said is, no doubt that the energy associated with a vapor is much higher as compared to that of ice. I very much agree with it. But the question is not about total energy. The question is, what part of this energy is vibration in nature? That's the question here. When you supply energy, let us say I take a container of gas, lots of gas molecules here. Okay. When I supply energy to it, what will happen to these molecules? Will they stand here? They will never stand. But instead, what will do? They start moving like this randomly. One molecule will go and collide with the other molecule. It'll get the zigzag motion like this. It goes like this, like this, like this. Okay, it'll hit the containers. Okay, it'll get reflected like this. Do you call this as vibration? No, right? It cannot be called as vibration. So therefore, the energy associated with the gas, okay, would be very, very less for vibration, right? Now, liquid. Let us consider liquid. In case of liquid, when you heat, now what happens? There are water bubbles which starts coming out from here. Okay, here also the molecules are being not tightly held, they are loosely held. So vibration here is also much lesser. In solids, when you heat, if this is your solid, the atoms are firmly held like this and they start vibrating above their mean positions. Do you break them at any cost? You never break them, right? So as a result of this, you observe that the energy in case of the vibrational energy in case of the solid is much higher as compared to the liquid or gas. So which is the right option here? See, liquid, no, this is wrong, this is wrong. So C is the right answer. Okay. So this is how logically one needs to think. So for this to understand what you need to do, you need to read the question once again. Okay. Thank you friends for watching. So if you like this video, do share, comment and subscribe to my channel for more updates. This will really help me out in recording more number of videos, which will really be helpful. And if you have any video, any problem that you feel okay is a misconception, just post it on the YouTube, or maybe you can send it to my email ID also. It is ratankar@gmail.com. Let me write it down if you want. Where is it? And write it down my email ID. I'd be happy to answer you this conceptual question. Okay. Thank you friends for watching.